Good morning, everybody. Today we will continue on a lecture we did a few weeks back where we built a message board from scratch with a client side, a page that shows the messages, and a server in express.js that is happy to keep and serve those messages to us. We had a bunch of stages. So what was stage one? Stage one was just a web page that shows some messages here. One day this will be a message board. Until then we can dream. And this is where we could start thinking about, let me close these windows. This is where we could start thinking about what should be in the page, right? What should go in a message board example. Then we proceeded through a few stages of building the server. And at stage 5, at stage 4, we had a long-ish server code. Let me make this bigger so that we can all see it well enough. We had longish server code, and it combines two things really. It combines the functionality of keeping messages and adding messages and so on, with the functionality of the server, where we are using the Express module to serve something on messages and serve something on for every message and so on. What did that look like? Let me run stage 4. And when I refresh, we have messages. And I can post a message that says hi, and it's there. I can refresh this, and the message hi is still there. And when I hover over these messages, then we see the status below at the bottom of the page here, updating to when this message was created. When we have the first 3 messages, they have these just textual times, an hour ago, yesterday, and last week. And we can retrieve information about messages. We have a root in the server that gives us information about any message. If we go to /messages and some message ID, we will get information about that message. Let me copy a message ID from this message posted, so to speak, an hour ago, and just go to /messages/that_ID, and we have JSON information about that message. That's what the page uses. Whenever I move my mouse over one of these messages, it retrieves the information about that message and puts it in the page. Now, that was stage 4, and the server code got a bit ugly because it combines many things. And I want to refresh you on what we did for stage 5. I will go to here. This is the GitHub page for the stage message board. And we can see stage 5 is refactoring as a module. And we can see the differences between stage 4 and stage 5. Firstly, in server.js, we remove all of the message handling code and we replace it with just code that uses our own extra module. We call it MB for message board. And then the code in server.js is just a server that deals with HTTP and Express. And then we have another piece of code in messageboard.js that deals with all of the messages stuff. This one doesn't know anything about HTTP. We have list messages that just returns all the messages. We have find message by ID, which returns the message or null. And we have add message, which adds a new message to the list and cuts the list to just 10 elements. This modularization separation of the code is really very important, and we had a whole lecture on modularization as well, so I wanted to refresh ourselves on this. In stage 6, we added a possibility to update messages, and in stage 7, we added the styling. So Until stage 7, we didn't care about CSS at all. We just made it work. And in stage 7, we then looked at what it should actually look like. We made it prettier. So let me show that. I will start stage 7 now. And if I reload this, my hi message is gone now because I restarted the server and we keep all of the messages in memory. But I can add a hi message again. I can add a new message again. And this works and it's nice and highlights a message that we hover on, and it's really nice. We can edit a message by going to this page and change this new message to new message, edited, update. I have pressed enter, it very likely updated. Now I can go back to the list of messages and we have the new message edited in here. So this is where we ended in the lecture a few weeks back. This is where we wanted to get to. We created a server that, let me bring up stage 7 server. We created a server that has some HTTP routes. At /messages, it will give us all of the messages. And will give them to us as an array of objects in JSON. At /messages/ID, if we supply the ID as a parameter, we will get information about a single message. We can also put into /messages and ID, and we can replace a message. We can edit it. And of course, this old route at post@messages allows us to add a new message. So this is a simple server. Now this server, like I said before, it stores the messages in memory. It has an array here with the messages and always replaces the array whenever we add a new message. So it puts the up to 9 old messages with the new message together and puts that in the array. And this lives in memory. If we stop the program and restart it, then we will lose all our new messages. I will go back here. I'm reloading this. We have hi and new message edited. I will stop the server and I will start it again. And if I reload it, we don't have any of the new messages because they are gone. The program has finished. So let's now ask you. Obviously, our message board server needs to store those messages somewhere. We need to remember the messages so that if we restart the server, we still have those messages. It would kind of be useful, right? We cannot expect a server always to run without restarting. For example, when we create a new version, we have to restart the server so it takes the new version of the source into account. We need to store those messages. So you tell us, what options do we have for storing those messages? I'll open the chat window.
Gurvir has suggested a database.
Yep. So Gurvir and Gareth are saying database. Alex is saying file with a question mark. Alex, why the question mark? I don't know, just a guess. Okay. Yep. So we have so far seen 2 options, database and a file. Do we have any other options where we could store the messages? I'm still watching the chat, even though you probably cannot see it on my screen.
There's quite a few options.
Rich, can you name a third option?
Yes.
Please do.
We could store everything in the clients, and then when the clients reconnect, they could resynchronize through the server all previous messages that have been sent to them, and then share them in a kind of magical peer-to-peer system.
Wow. That is absolutely possible. We can have no storage on the server, so that if the authorities, blockchain message board, lovely. If the authorities ask us to provide all the messages, we can say our server doesn't have any. We could have the messages in the clients, yes. We could have some kind of blockchain message board where we cannot take messages away once they have been accepted. Right. So the main two options would be database and file. They are straightforward. They are for storing stuff on the server. But forget about files. Why do I want you to forget about files? And now I'll be talking about them for 5 minutes. Because how do we store stuff in a file? When stuff comes in, we just overwrite the contents of the file, right? Or we append to the file. What if the system goes down while we are overriding the contents of the file? We might lose the file.
Oh,
What if the
I know.
system... Yeah,
I know.
Rich?
We create a grandfather father son backup system, and so every time we want to update the file, we make a copy of the file, and then we update the new file that we've just made. That's a copy of the original file, so we're doubling our file size.
Oh, yes, yes, yes. We could double up our file size and be fairly safe. Every time we are writing a new thing into the file, we could take the old file, copy it, sorry, take the existing file, copy it into an old file, and then overwrite the existing file, and then make a flag so we know we are done overwriting. And then we would know, even if the system crashed, that we do have a safe version of the file. Right. Then, of course, once the message database, I'm calling it a database, but once the message file grows, this copying would actually take quite some time. We couldn't make Twitter this way because they are getting millions of messages every second, I expect. And it would be impossible to just copy that file full of messages over again and again and again. So they would have to batch it, and we could do it. How do you connect a database such as PSQL to your server? Asks Gurvir. Gurvir, you are getting ahead of ourselves. We will get there in a few moments. We are talking about why to use databases, because we could do this with files. We could get really clever and put updates in a file so that if the server crashes mid-update, then we would be able to roll it back, and we could just append the updates. So every update is a tiny little addition to the file, so it's unlikely to crash. And we could do this with files. In fact, we know that we could because somebody else has already done this with files. Every provider of database software stores the database in files. They were and are some very clever people that have created software that, given an update to some data, stores it in a file, and if the server were to crash, then it can restore the data to their most recent available view and all of that. We could do this with files, but we would have to recreate database software. So what we do instead is use existing database software, because making a database is not our business. Hence, the first two options that were suggested, a database and use a database by Gurvir and Gareth, were absolutely correct. That is how we store data. Now, I'm talking about data. We will soon see, today I believe, that there are exceptions to the rule. When we want to store stuff that isn't easily seen as data, then we may not want to use a database, and we will get to that. So, yes, just like Rich wrote, databases, they do the hard stuff for us. Indeed, that is the trademark motto for every database software out there. So, what database options do we have? I wanted to ask another question. If I have a database right? Let me bring up this. This would be a this is a terminal on my VM. You have your VMs and you are very likely using them in your databases classes. So this is mine, and I'll connect to my database. Very good, but right, I am not connected to a database yet. I'll create a database and then I'll connect it. Create DB messages, why not? Create DB is a command that comes with Postgres, and PSQL messages, I should be able to connect to it. Right. Does anybody remember? Can anybody suggest to me how we would put those in the database? I'm opening the chat window again.
When you say put those in the database, which is the those you're referring to?
Right. We have messages. That was a good clarifying question. We have messages, and what do those messages have? Let's have a look in the code. In the code, they have ID, message, and time. If we go to messages, we see, yes, ID, message, and time. So this is the data we want to store in the database. Does anybody remember how I would do it with Postgres just by actually manually doing it in Postgres? Have you done any of this? Have you stored any data in Postgres yet? You first need a table, right? Yes, Joseph, exactly right. So, give me a table. What's it look like? I won't ask you to do everything here, but I would like you to give me a basic table structure and the syntax for it, please. Somebody. Table messages. So, table messages. That doesn't work. Somebody's furiously typing, I hope. Create table messages. Ooh, yes, of course. So, create table messages. And we will need to have some columns in there. What columns would you suggest? ID of type. We will have messages as well. Messages, MSG, and time. That's right. Create table message, and then your columns, and then, yes, exactly. This is exactly what I wanted you all to start thinking about. If I had that table, I could then query it. Actually, I believe I do. Message board, right. Do I have that table? How do I ask Postgres to show me my tables? Do we have something like show tables? No, I don't. I never remember because I grew up with something else. Select statement /d/l. I think, yes, /l lists all the tables, message board, or maybe it lists databases, /d, right, public message board table, right. Ooh, it's called message board. Select star from a message board. Yes, that is exactly it. Thank you very much. Well remembered. So this is how I could work with the database if I was doing it by hand, right? And I'm jumping ahead a bit on purpose. That actually had some messages. These are 3 default messages delivered from the server using a custom route. Ahoy, testing, testing 2. Those are messages that I currently have in the database. Let me run. Okay, I will need not that. This. I will need to start the server. npm run, and this will be stage 9. And I want to show that this actually runs. If I go to my server, it's not running just yet. It should be running now. It is running now. And we have, these are 3 default messages delivered from the server using a custom route, ahoy, testing, testing 2. These messages are actually there. Let me do a new terminal and go back to PSQL message board. Cool. I will by hand insert a message. Insert into message board MSG values new message. SQL can fill in the ID and it can fill in the time, so this should be enough. New message. It has worked. And if I reload here, I see the new message right there. So we know how to create a message. We know how to select all the messages from a table. And we know, I'm sure that you would remember this one as well, insert into message board. So we know the SQL. How do we connect it to our code, right? That is what today is about. So let me go back away to my local system, close the chat, which is in the way, and let's have a look. We have stage 7 style, and this is where we finished. Now let's look at stage 8, data belongs in a database. Let's first identify the differences. So we have some differences in messageboard.js. That makes sense. We have some SQL. I'll get to it in a moment. Do we have any differences in the server? Let's start with the server code because this is where this is the bit that changed the least on the server. We have our message board stuff in messageboard.js. I'll get to that. But that message board now deals with the database. Databases are, and I'm not saying this lightly, databases are slow from the point of view of a CPU compared to access to memory. Databases are really, really very fast compared to accessing disk files on our own, or even worse, accessing something over the network. But compared to CPU access to memory, databases are slow. So we do not want to block access to our server when we are talking to the database. We do not want every client to be waiting until one client has finished talking to the database. So the changes in our server are just a lot of async and await.
Can I point out here something, Jack?
Yeah?
Don't be fooled by the large red or the large pink and green lines. They're there to draw you to attention to that there is a change on the line. Then on each line, it's only the darker green bit that's important. That's the only change. So what you see when you skim read this is actually there's only async and await are added in each spot. So it looks like there's a lot of changes, and actually there's very few when you look at it in greater detail.
Indeed. So the module, the database module, cannot be synchronous anymore. We are not accessing just our memory. We are accessing the database. It has to be asynchronous. So we have to await the results, and to await the results, we have to do it in an async function. So everything here that we have in the server has to be an async function now. Now, because Express was created before promises were available, and before async and await was available, Express doesn't know about async functions. So we have a little helper function, and we won't go into the detail, but this helper function, which we call async wrap, wraps an async function so that express.js can handle any errors if there are any errors. If we didn't do this and there is an error, our request would just hang and it would never close, and that's a bad idea. So this function, when you start dealing with asynchronous functions that handle your routes, like we have here, get messages, get message, put message, and post message are all asynchronous functions. You have to, for them to work nicely with Express, you have to wrap them so that you handle errors, and this async wrap function does that. If you want to know the details, then try to parse this very dense code, and if you have questions, ask. But if you don't know any of the internals of this function, that's absolutely okay. So that's what changed inside the server. We just added async and await in many places, and because of that, we added some async wrapping to make this work nicely with Express. But that's the only big change really in the server code. Right. I will get to the SQL now in a moment, but I'm sure that we have more files than just 3 in there. We are coming from stage 7, and stage 7 has server.js, messageboard.js, and a bunch of client-side files. Client-side files that give us the user interface. They give us the message board and load the messages from the server and give us a page about a message and allow us to update the message and have nice style. Guess what? We are adding a database. That's a big, important change on our server. And the client doesn't even know about it. The client totally doesn't care. For all the client knew way back when, the server already had a database. The client that we can see in here, this is stage 7 running, I believe. Let's reload this, yes. Message foo and message bar, why not? For all the client-side code knows, these messages are stored in a database. It's only the server that actually knows they aren't yet. So let's go back in here. This was stage 7, and in stage 8, we only have changes in server.js, which we've already seen. I'll close it now. And then changes in the message board module. And we have the SQL. Let's look at the SQL now, because we have to have some code to prepare our database. And this code best lives in an SQL file. So I have here a file. It's called a migration file because it allows us, let me show it in the editor instead. It allows us to migrate the database from how it was, initially it is empty, to how it should be. With migrations, we can evolve our database, and we will see that in a few moments. So that's why we call these migrations. When we want to change our database from one version to another of our program, we have to migrate the data that's in the database. We can't just delete the old database with all the messages and create a new database for version 2 of Twitter, because yeah, users wouldn't be happy if all of their messages changed every time Twitter upgraded. Sorry, if all of their messages were deleted every time Twitter got upgraded. So what does that SQL code look like? We have already created it. You have told me how to do this bit. Very good. And we can choose a length for the ID. We use UUIDs as we talked before. So we have 36 characters for every ID, and that's a primary key. Every message is an unlimited text, and time is a date time. This date time thing is a special type in SQL that gives us the current time, or well, that gives us a representation of time. It's a number, it isn't string. Then, when we're setting the database up, we put 3 basic default messages in there. Why do I have these in here? Because in stage 7, in messages, no, not the client code, in messageboard.js, I had these 3 messages in memory when I start the server. And I want to replicate this in stage 8. I want to be able to start with the same messages on the screen. So, coming back to the SQL file, we have very same messages in here. These are 3 default messages delivered from the server using a custom route with those IDs. So we can move these default messages into the database when we are creating the database for the first time. This was creating the database. If for some reason we want to migrate back to the version before, which sometimes happens, not usually with the first version, migration here would just be dropping the table, of course, because version before the first one doesn't have anything in there. So this is the SQL, and you've seen this done live, and you've done this in your databases module in Postgres, so you know how this works. So now is the key question: how do we connect the server code to a database? We will not start with PostgreSQL because there is a simpler option. That simpler option is called SQLite. SQLite, often pronounced SQLite, is a fully fledged database that doesn't run outside of your program, but it runs as part of your program. And we will be using it here. So let's now look at stage 8 messageboard.js. That is the file that changed the most. And I will actually bring up stage 7 messageboard as well and put them side by side. So
while Jack does that, I'll mention that the reason that you might want to have this happening as part of your program, not outside, is if you don't already maintain a database, but you do want the simplicity of having the database software manage your data for you and do all of that ugly file stuff, then this is brilliant because you don't have to install and maintain a database separately.
Yeah.
It gets you started down the database road, and then later on, if you find that you now have a need to grow to a bigger database, then you might then think about going to Postgres or something else.
Yeah. SQLite has the word light in the name, but it's no lightweight. It is a real database piece of software. But it runs as part of your program. So if you are making the first server of some sort, you can use SQLite, and you will have the database and the server running on the same computer, and it's all nice. But at some point, when you start getting thousands or millions of users, you will start not hitting the constraints of SQLite, but you will start hitting the constraints of one machine. If all of this runs on one machine, that machine has a limited CPU and it can only handle so much traffic. And you will want to scale so you have more machines involved, and then you need to have a database that's outside of the server machines, and then you need to have database accessed over the network, and that's what SQLite doesn't do, but Postgres does. Until then, SQLite is great. So in the stage 7 message board, and a lot of time before that, we had an array of messages, and we had 4 functions exported: list messages, find message, add message, and edit message. We have in here, stage 8, the same 4 functions exported. I will highlight export, and it is here: list messages, find message, add message, and edit message. The API of this module called messageboard.js has not changed, except for the bit where we have added async. These weren't async, these are async. So we have to deal with these functions asynchronously. That's what we did in the server. So other than that, the API is the same. What does list messages look like? Let's jump right in here. We get some kind of connection to the database. Even if SQLite runs in our server, we still have something called a connection to it. And then we do select star from messages, we order by the time and descending so that we get the newest messages at the top of the list, and then we limit this to 10. Previously, we just returned all the messages, because when we were adding a message, we made sure that there weren't more than 10. That is because we didn't want this thing in memory to keep growing forever, because we would at some point run out of memory. Memory is much more limited than disk drives. When we have a database, we store our messages on the disk, so we no longer have to limit the stored messages to 10. We just return the 10 newest messages. So this is a very simple SQL query that gives us the 10 newest messages. And this db.all function is provided to us by the database connection. Let's look at the database connection now. The database connection is the result of an init function, and in the init function, which is ours up here, we open the file called database.sqlite. .sqlite is the normal file name extension for SQLite databases. The other normal extension would be .db. Use whichever you prefer. So database.sqlite in here. We open that file with SQLite, which is a module we get from npm. Then we have this migrate thing, which just takes our code, and if the database isn't there, it puts the database there. If we have 3 different versions, then when this code runs, this migrate call, which is very useful coming from SQLite, it just puts the database in the right version for us and returns the connection. The connection comes from SQLite.open. How did I know these things? This all comes from the documentation. Not of SQLite, which is a library in the C language. It is usable in most any system, but npm SQLite. Now, when you look for SQLite on npm, the first that might come up is something called SQLite 3, but that's an old API. Don't use it. SQLite is the new API. That's the API that you should use. So let's go there, and we can see how to use it. We have to install it. We have to install SQLite. Of course, SQLite 3 itself will be used because SQLite, the new library, uses the old one. And then what do we have? We have open. So we could do it with await async. We open the database. We don't have to give it the driver because that's filled in by default. And then we just use it. And because we're using asynchronous functions here, we await the opening, and then we have the connection, and we return it from init. That's inside dbcon, but init is async, so everywhere where we use the db connection, we have to await it. So this db variable has a connection to the database, and then we can run a query on it. db_all gives me all the results of a query. db_get gives me the first result of a query. Here we have the find message function. Find message just gets a message by ID. Our ID is a primary key, so it's unique. So select everything from messages where that ID is going to give me just one message, because a primary key has to be unique. So we know that we're getting just one message, so we use db.get to just take the first result. db_all returns an array of results, db_get returns just one result, and so on. So this is how we connect to a database. This is how we use SQLite database, and the file is database.sqlite. Where does this file live? It lives wherever we run the software. So it's not showing up here because I have it in git ignore. I thought, where is my database.sqlite? I must, oh, of course, I haven't run stage 8 on my computer yet. What we've seen was stage 7. So I have to stop that, run stage 8. Up crashed. I haven't done npm install yet. I apologize. This gives me time to have a sip of water. Very good. Now let's run this. Oh, what has happened? Have we made any changes to this? write, do we, module not found, node SQLite 3, what has happened? What have we done in changing this? In package.json, we have SQLite among our dependencies. So I do believe that it was telling us to install SQLite 3 as well. So let's install SQLite 3 because SQLite uses that. We always break something, don't we? And because we do, everybody does, it's very important to be able to read the messages that your computer is giving you. I was going through that long message and I figured out that very likely what it was missing was SQLite 3. Now it's building it. So let's give it some time and let's look at the code of the remaining two functions. We had list messages and find message. That's just select, right? But we can also add a message. And how do we do that? We, again, get the connection to the database. We create a new UUID. Sometimes the database can do it for you, and we will see that with Postgres. And sometimes you can do it yourself. That's absolutely okay. I will hide this compilation some more. And so we create a new UUID for the new message. We get the current time, which has to be in ISO string format. So we have a function current time that gives us that. And then we run a query. We're not expecting results here. So we run a query, insert into messages, values. And what's with these question marks? And actually come to these question marks. What's with this question mark? We were finding a message. If I take this function, if I take this query, actually in Postgres, it is called something slightly different. So if I go to my Postgres and I do select star from messageboard where ID is question mark, it's gonna bail. It's telling me question mark doesn't, it's not SQL, right? What's up with this question mark? Can anybody guess what is up with this question mark?
Jack, I don't know what's happening, but I keep on getting muted by something, so I'm not able to talk to you, and I'm trying to.
Oh, that's strange. That's very strange.
Jack, can you rewrite line 19 so that it uses concatenation?
Rewrite line 19 so that
or copy that one and then make a replacement for it.
Oh yes, absolutely. I'll first have a look at what the chat says. It inserts the ID value where the question mark is. Joseph is right. You have multiple IDs, so that's why it's a question mark. Gurvir, you're not getting it quite right. We will get to that in just a moment. Placeholder for value. Yes, Sanjeev and Alex, you are right. And Joseph got it right as well. So.
But why do we need a placeholder?
Exactly. What Rich was suggesting is the straightforward way to make a query. So let's do this. I will keep this code for later. And what we want is const query is, and this thing. So instead of the question mark, we want to have that ID in there, right? So let's put the ID in double quotes plus ID plus that.
I'll use the backtick syntax, it'll look prettier.
Oh yeah. Yeah, that you're absolutely right. Let's use the backtick syntax. So change this to backtick, change this to backtick, and then we can just do double quote, because that's where the ID is going to be, and then the value of the ID, and then the closing double quote. When I do this, the query will look like, let me go back to my Postgres and hide the chat again. The query will look like that ID like this. Let's go back. Boom. The query will look like this. Of course. What's wrong? Column. Oh. Databases like their single quotes, especially Postgres. What's wrong with here? Select star from messageboard where ID is this. Invalid input syntax for type UUID. Oh, of course. It's not actually that. Select star from messageboard. In Postgres, we use UUID, so let me get that instead. Good. And we have this result. It's one row. I'll make the window bigger so it stops showing me a page only, because now it can show me everything. Good. We have this result here. So we have our message. That's all right. So this would be a way to do it. Create the query by putting the ID in there. Actually, it wanted to be a single quote in Postgres, and I think SQLite doesn't care. And then run the query, right? So why did we do it with the question mark? Can anybody guess? Somebody might already know what the problem is without the question mark. Caleb, it's vulnerable to SQL injections. Caleb is completely correct. I've closed the chat window again because Caleb hit the nail on the head. This ID, where does it come from? It comes from where we call find message. So find message, where do we call find message? In stage 8 server, that's the one, find message, we get the ID from parameters. Where do these parameters come from? They come from this colon ID, so slash messages something ID, right? Let me run this code. Let me try to run it. Let's see if all that SQLite stuff is now working. And npm run stage 8. Ooh, we seem to be in luck now. Not this window, this window. So back to here and here. Reload this. We have those 3 default messages in there. And let me try to add a new message. Hi. It seems to be there. How do I know whether or not it is there? What I will do now is kill the server, run stage 7 again, which doesn't use the database, and I will make this smaller because I need to see both windows. Reload this. We don't have that message hi. I stop stage 7, run stage 8 now, reload this, and we have hi. Hi is now there, and it has survived a restart of the server. And where is my database SQLite? It's in here. In stage 8, we have database SQLite. That's what's holding my data. So this is great. So what was the message ID for this one? It was that long UUID, right? It's this long UUID. So I can take this and go to localhost 8080 messages / that UUID, and I have this. Cool. What if I change this ID to something different, like just LSJD? No match for that ID. That's fair enough. The database is telling me I don't have a message like that. And what if I do, what did we use?
Let's do Bobby tables.
Sorry?
Let's do Bobby tables.
Bobby tables, yes. Apostrophe, what was it? What does it want to be?
How do you drop tables in SQLite? Apostrophe, semicolon, drop tables?
Actually, I just added one apostrophe, and we already are seeing SQLite error. So absolutely correct. Apostrophe dash dash drop table messages, I believe. Semicolon. Oh, dash dash is no, semicolon drop table messages dash dash. That's Bobby tables, I think. No match for that ID. Yeah, that's probably fair enough. Do we? We still have those. That didn't work. But I was trying to do SQL injection. But yes, there's a lot of spaces in there, and that gets encoded. So, didn't manage to properly exploit this SQL injection possibility. Play with it, and you find out how to properly exploit it. I have high hopes that Caleb might be able to come up with that, having already known about SQL injections. But we have made the SQLite tell us about an error. When we get internal errors in our software like this, that's a bad idea. We should not let the user give us data that triggers internal errors, because that's normally where security issues happen. So, moving back to the code.
So we have a
that
question
was,
from Jamie to say, can you use SQLite with PHP? Quite possibly if you were writing code in 2002. And would PHP be easier for stuff like this? No.
sorry, I'll get
PHP would not be easier, it would be slower.
Right. Can you SQLite with PHP? Yeah, no, it would be a bad idea because PHP uses multi-threading. We have showed you how to put together a query by putting a string in there. But that's a bad idea. I wasn't able to actually abuse it to delete the database just that quickly. I don't have practice in that. But what we do is we give the database a query kind of pattern, a prepared query with question marks where I want my values to be. And then I give it those values. In this case, there's only one value, and that's the ID. And the database makes sure that this value gets put in there so that it is not abusable, so that it is treated safely. If you find yourself putting queries together as strings, you're very likely doing something dangerous and bad. So don't. Always have queries with variables like this, in this case question marks, and provide the values so that the database software itself will make sure that there is no security problem. Database people have worked on security problems for a long time. They can be trusted to put these strings there safely. We can't. This is stage 8, and it's actually working. We have a list of messages. When I run this, because I have stopped it again, we have a list of messages here, and it remembers the message that we put in there. Data belongs in a database. In the next bit, we will look at how to connect to actual running Postgres instead of SQLite. These are two different options. Both are very much allowed and valid. And finally, we will very likely extend the server to do something new and cool that you haven't seen in this example just yet. We have gone through stage 8 of the staged message board, where we added a database. We started putting the messages into actual permanent storage so that even if we restart the server, we still get the data. Do we have any questions so far, please? We'll give you a few moments, and then we will start looking at stage 9, which adds Postgres, and the differences between that and stage 8. So the question marks were for security. Yes, absolutely. Security and general stability, but they go hand in hand here. We don't put strings into SQL queries our own. We let the SQLite library do it. We let the database libraries do it, so that it is guaranteed that there are no security issues there. Cool. I will start sharing again. Very good. We are here. Sorry, I need to get my... When is Zoom in the way of itself?
A bit of background for Jamie's earlier question about PHP as well. PHP exists as a plugin in Apache normally. So there's a fundamental difference between what we're doing here in JavaScript and in PHP, in that Apache is your web server and it's got this plugin called PHP. So when a request comes in that Apache realizes is a PHP request, it has to use its plugin, which itself is slightly slower. Then the thread itself is created, or the request itself is created as a new thread. So there are processor overheads for that. And that on the whole can make things slower. The major difference between that and the way Node works is that rather than having an Apache web server with a plugin, you are doing everything within the Node environment. You're building the server yourself. You're already in the single process that gets used. And we've talked about JavaScript being single threaded. And the beauty of asynchrony is the example that we showed you earlier on in the little slide where we had the long thread where we wanted to do something and waited for the network, then we wanted to do something else, we waited for the network. And with asynchrony, they can happen pretty much almost at the same time. And asynchronous code is almost as fast as parallel code, but it doesn't have any of the overheads. So what we have found, and this was that the reason that Node suddenly took off 10 years ago, was when people started writing web servers in it, the web servers were as performant as ones that were compiled, but way better in terms of memory utilization and all of the annoying stuff that happens in the background. So the reason that we're not doing this in PHP is that Node has come along and has actually showed us that there's a way more efficient way to do it than PHP. And the big advantage, of course, for us and for you is that we no longer have to have two languages, one for the client and one for the server. Now it's just a single language with libraries that can be used on both. So that's why we're not using PHP anymore. We used to teach it in our second year web script programming module, which is the module that eventually migrated into Node as its primary language. And then the content of that module is what we brought forward into the first year for this module. So it's stuff that we did teach up until about 6 years ago.
And we can teach it at first year level because it has become easier to work with. And the code is much more maintainable this way as well. So, coming back to our staged message board, we were on stage 8 and we had some messages in the database. Very good. Now, let's look at what we should do if we wanted to use Postgres instead of SQLite. When, for example, you already have a database set up and you want to connect to that, that's a good case where you should choose Postgres over SQLite. Or where your server is running out of steam and you need to split the database away from the server so that you suddenly have multiple machines working on the same task and they can share the load. So let's look at the differences between stage 8 SQLite and stage 9 Postgres. Now, in Postgres, we are connecting to a running database. That running database is not part of our program. We have to connect to it, usually through internal something like networking inside the computer, or in fact over the network if we are going to a different computer. To know where that Postgres database lives, we usually have some kind of configuration. In our examples, we assume that the Postgres database lives on the same computer where the message board server lives. So we have a configuration set up here that just tells Postgres to connect, tells the library to connect to Postgres locally. Now, if you have Postgres running on some other server, this host would be the IP address or domain name of that server, and you could have port and password and username and stuff like that. Here we are running locally, so we just do this. Now, this is set up for our VMs. You have your VM with that you're using in databases, but if you have Postgres running on your own computer and running Node on that, very likely you will not need this line, so you should remove this line from config.js if messageboard is struggling to connect to your database. Right, then we specify the database name, in our case messageboard, and a statement timeout, which we could probably have left at default anyway. So that is a new file, config.js, that we had to add. Let's skip over messageboard for now, because that's the code changes. We no longer have the SQL migrations file that looked like this, that was created for SQLite, because Postgres does not give us migrations like this. We can't just have automatic migrations with an external server. We have to make sure that the server we are running is actually expecting the database to be as it is on the other server, because other software might be using the same database server. We can't willy-nilly just update the database. It is not entirely under the control of our server code. So instead, we have a file called messageboard.SQL, where we have the SQL for setting up the database in Postgres. And we start by pulling in the UUID extension for Postgres. Then we drop the table if it was already there. We're actually dropping all the old messages. But this file is intended to run only when you are completely recreating the database, not otherwise. Then we create the table, and then we put in the default messages. In Postgres, we can have a default UUID, we can have default time, so we can just insert the strings of the actual message content. So we have replaced a migrations SQL file with just a setup SQL file. For that, we also have support in package.json, which we haven't looked at yet, but we have been using these stages. Stage 1 through stage 10 each have a run script, so that's why I was able to say npm run stage 8, and it would just do the right thing. But we have one more thing that is necessary for Postgres, setup PG. When you deal with a database piece of software, you should assume that the database isn't there yet when somebody's installing your software. So you should let them create the database as some kind of setup step. And here we have a setup step for Postgres, that's why we called it setup PG, that creates a database called messageboard. And if that creation went correctly, then it loads the messageboard SQL file and executes it in that database. So these two commands will create the Postgres database for you if you don't have a database for messageboard just yet. You don't have to do it manually. You should not require people to do these kinds of setup steps manually. You should give them a setup step, preferably as a script in package.json. So we have this, and this line was added for stage 8. But we are not showing it as part of the diff in the browser on GitHub because it is not inside the files.
Yes, I'd interrupt you briefly there, Jack. One thing to note, in your coursework, we do specifically say, if your application requires a configuration step, this must be achieved via the command npm run setup. and documented in the README file. So this is a perfect example of that kind of setup, where there's something that needs to work until we've got it set up.
I could add an alias for setup PG by adding a script called setup that just does npm run setup PG. So if you have database or anything else that needs to be set up, you have to provide a script called setup exactly. And we will call that on our testing machine. Good. So that's how we create the database. Now, the code isn't really different. The SQL code isn't really different. I had it in here. We have create table, message board, create table, messages. We chose a different name, but these names really are up to us. And very seldom would we have two different databases at the same time. So we just choose a name that fits.
An interesting point on that, of course, is that the front-end code doesn't care what the back end is called. The API stays the same, so we can call it anything. And the reason that we were able, or that we did call these two completely separate names, was that Jack and I developed both these solutions in parallel, and we weren't speaking to each other. We were just doing them totally separate. So that was why we ended up with two names, and it just doesn't matter because the front-end API means that we're completely oblivious to it.
Yep, exactly. Actually, the front-end API, that's defined in svr.js. We do have one change in svr.js that just changes the comment that says where we are, from stage 8 to stage 9. That's the only change in the code that then defines our routes. I uncover all of this, that we have exactly the same routes and exactly the same handling functions that deal with the messageboard.js module. So the server code hasn't changed and the client code didn't have to change either. So let's now have a look at the really important changes in messageboard.js. And this no longer makes sense to do in a side-by-side diff, because those messageboard.js files are really quite different. They do deal with, well, somewhat different. They do deal with two different databases. Let me kill that and close it. I will no longer need it here. Stage 9, messageboard.js. Is it actually shorter than in stage 8? Probably just because of code style, because this is less dense. So I brought these up side by side because I want to compare the one thing that's important for a module to the outside world, and that's the exports, the API. Export async function list messages, export async function list messages. The exports are exactly the same. Both of these have to be handled asynchronously. So the export lines, export async function edit message with one parameter, export async function edit message with one parameter. It's the same API. That's why the server didn't have to change.
Yeah, the Postgres code could be a bit smaller. Obviously, we've got an extra line. So on the left-hand code, the queries are being built within the return statement. In Postgres, they're being built beforehand for perhaps a little more clarity. But the reason that Postgres is particularly much smaller is that we're not having to create UUIDs as well. So that saved us a line or two.
Yep, exactly. In Postgres, we can use an extension that gives us a UUID automatically if we want them. So that's nice. Let's now look just at the code. So how do we connect to Postgres? We have chosen a library called PG that we load from npm. Let me go there, npm PG, very good, that's the one. PG is a common abbreviation for Postgres, and Postgres is a common abbreviation for PostgreSQL. So this is not necessarily the only library for dealing with Postgres, just like SQLite is not necessarily the only library for dealing with SQLite, but it is the one we chose. And it is nice, modern, await async. It is a very good one. When we installed this, we had to do npm install pg. But very importantly, unlike with SQLite, npm install pg does not install PostgreSQL on our machine. PostgreSQL is a software package that manages the database and runs there in the background. npm install pg does not install PostgreSQL on your machine. What it does is it installs just the node library that allows you to connect to a running PostgreSQL server that you already have installed somewhere. So I would have to install Postgres on my machine from which I'm presenting, but I also have Postgres running on my VM, just like you all have and have been using in the databases module. So I will be using that Postgres on there, and I will be running my code on there as well. So we have installed PG. Then how do we use it? We import Postgres from PG. That's the common way of doing this. And then we create a new client, because Postgres has several other parts of it. We need to have a client that connects to a running Postgres database, and it uses the config. I have already shown you the config briefly. Let me bring it up again just for a moment. I was trying it on my computer. That's why this host thing is commented out. But this config is meant to be changed for the current running environment where we are running this. So I will go to my server. I am here on my server where I ran stage 9. I will show you the config. So cat for basically output, stages 9 config. That config file has the host in it. When you develop locally but deploy on some server like your VM, you have to make sure that the config files, if you have any, match the target environment. You can't just copy the config file from your development machine over to the server. That takes some care. So I wanted to show that that config file on the server on my VM differs from the config file on my development machine. Right, coming back to the message board code, we get the config, we get Postgres, we create the client with that config, and then we connect to the running server, and we also set up basic error handling. So if we get an error message from the SQL connection, then in our case, what we will just do is write out SQL fail and finish the connection. But of course, that means our server can no longer talk to the database, and maybe that problem was transient. Error handling with network connections and connections to databases is more involved than this. What we really want to use is a pool of connections, but that is too advanced for this class today in application programming. So that's why we don't use that in here. We just use a simple client. Right, and if an error happens, we just bail. That's okay. This is not production code. And what does the rest of the code look like? We list messages by doing select everything from message board, order by time, descending, of course, again, so we have the newest messages, limit 10. That's actually very, very similar to our previous query in SQLite. Find message. Select star from message board where ID is, oh, no question mark. The PG library uses $ and number so that we can have parameters and we can have multiple of them, and we have exact control on where each parameter goes. So $1 is just like the question mark in SQLite. It takes the first value from the values that we provide to the actual querying function, and it puts that value in here again securely. In SQLite, it was question mark. In PG, it is $1, $2, and so on. They are equivalent functionalities. And this is showing you that different libraries, different databases, and so on will have different conventions. And you have to be ready to look for those new conventions and learn them as you use a new product, like a new library, like a new database, that is. So find message gets that. And then we have a function called SQL query. We give it that query. We give it that query with the ID. And that in Postgres, in this PG library, always returns an object with rows. So even if we are asking for just one result, it gives us an array of rows. If it didn't throw an exception, if it didn't tell us that something went wrong, then we assume that we got one and we return that one from there. If it didn't find the message, then this will be undefined, so we are returning undefined. So this is find message. Add message does the insert, and edit message does the update. These are just your normal SQL queries. With update, we have to set the message to a value where the ID of that message is that. Otherwise, we would be updating all the messages to the same text, and that wouldn't be right. So this is our code. It is a bit denser and a bit shorter than SQLite. Postgres does the UUID for us. Other than that, there's very few differences, really. But those differences matter. Stuff like, if you put question marks here, it wouldn't be guaranteed to work the same way. If you put $1 in SQLite, it would very likely break. So you have to know those differences, and you have to target the database that you're using. Does this work? I've already ran it. So if I run stage 9 again, and I connect to my server there on my VM, I reload. Oh, why is it not running yet? I reload, and we have all of those messages, and they are in the database. If I change testing 2 to testing 2, let's say edited, because why not, update, I can go back to the list of messages, and it will show testing 2 edited. So that was stage 9 that put the data in a Postgres database, very similarly to stage 8, which put the data in a SQLite database. Any questions?
While you're thinking of questions, there's a comment I want to make about this. If a message is edited, will the ID change? No, it won't.
No, it won't.
Having the IDs. The ID is a unique identifier for the message. If you change the message, you're using the ID to identify which message you are changing.
Yeah. What does the query look like when we're editing a message? Update message board, set MSG to the new value, where ID is the given ID. When we are editing a message like testing 2, we are editing a message with the UUID. That's because my window is narrow, it's short like that, but let's see the whole thing. This is the UUID of our message, and we're editing it by that ID. So no, we're not changing the ID. We want the ID to stay the same, because actually there's just no reason to do otherwise.
So
cool.
I'd like to make, Jack, if you can bring the source code up again just for a second.
Absolutely.
We've introduced the idea of modularity to you. We've said that modules are good. But what we've got here is a really strong example of why they're good. Imagine now that you're not writing this as a piece of coursework, but that you're 10 years into your career and you're now managing a team of programmers, and your Postgres expert leaves. So now you need to get a new Postgres expert in. But that's the only skill you need to hire for, because if you need somebody that's going to maintain this piece of code, you don't need to hire someone that's got Postgres and Node and HTTP and all of the front end expertise, because all of that is completely abstract from this. This is a modular piece of Postgres code. So you can hire someone in, they can maintain it, they can improve it, or if you decide that you want to change from using Postgres to maybe Oracle or MySQL or whatever magical new database comes out, you only have to change this piece of code. And that means that everything is more focused and therefore it's simpler to hire for. So
Yep.
easier to maintain. And maintainability is always something we have in our marketing scheme.
Yep. And like Rich already said as well, this module, it doesn't know anything about the client side. It has absolutely no idea about what it will look like on here and what functionalities the client has. It only provides these 4 exports. And in the same way, the client side has no idea about what this looks like because the client side actually uses only the API in SVR. And the API, oh, not this one, that's a different stage. So that was 9 SVR. Here we go. The API is defined here. And these functions just use the message board module to deal with the actual data. So strong separation of concerns. On one hand, we have this network API that separates the client from the server and shields the client from server-side changes and vice versa. And we have the API of the module itself, which shields the rest of the server and the client from changes inside here. We have completely changed to a different database. The code is not compatible, but because the API is the same, the server can use it and the client doesn't even know that there was a change.
We've got a question coming in from Usman saying, will message duplicate have different ID? And I've asked what message duplicate might mean. He said, like writing the same message 2 times. I'm not sure the exact example he's going to, so hopefully you've got a microphone.
New message. Cool. I have added a message with the text new message. This says edit me, and you can see at the bottom of my browser that there's a URL that has A6DF383D and so on. That's the ID. This one has 556E and so on. These 2 IDs are different.
That's the point of a UUID. It's a universally unique ID. Every time one is generated, it is mathematically very highly improbable in all of humanity that we'd be able to generate 2 that are the same.
Yeah. But also, you called this a duplicate message. Well, a duplicate message on a message board like that is just a new message which may come from somebody else actually that happens to say the same thing. If you come into a room and say hi, and I come into the same room and say hi, will those be the same statements? They will be 2 different statements that happen to have the same content. So from that point of view, we have 2 different messages here, even though their text is the same, and I can change the first new message to new message foo and go back to list of messages, and I have only changed one, not both. Exactly, Cosmin Gabriel is right, it would just be a new entry. Good. So that was message board stage 9 Postgres, and we had stage 8 SQLite. Now the other thing that we want to show you, and I will first run it and just show it. Okay. npm run stage 10. Let's see what stage 10 does. Here we have, right, this is on my Postgres server. Let's look at the local one. Ooh, it has changed. We have added functionality here. We can have a picture together with a message. The default 3 messages do not have a picture. But let me grab a picture from my computer, if of course it allows me to do that, but I have it somewhere else. I'll need to stop sharing for just a very brief moment. All right. I am sharing again. And now I can upload a picture together with my message. I could post a message that says hi and send it, and the message is there. But if I drag a picture of our beautiful Future Technology Center onto this button, I have chosen a file. I could have clicked choose file and then go through that, but I have chosen to drag it onto the button instead. And it says Future Technology Center Northern Quarter.jpg. That's the file I chose from my computer. And I add a new message, and it says, hey, look at our new building. And that, oh, it's an avatar. I'm actually using a building picture as my avatar, but sure, why not? And we have, hey, look at our new building, and we have the file here. In this stage, what we are adding new is uploading a file. You are very unlikely to need that kind of functionality in your coursework, but it is very useful in most other types of servers that we do, that users can upload some kind of file. Sometimes they share files, sometimes they deal with images and so on. On a message board, it would be natural to use some kind of avatar message so that people can post with little images of themselves or other images, because not everybody wants to show an image of themselves. So, how did we do this? Let us look at the differences first. Stage 10 is actually built from stage 8. It uses SQLite rather than Postgres because that's easier to run everywhere. So the diff compares stage 10 to stage 8. We start with, and I'll switch to the source code here for that. In stage 10, we start with a directory of images inside the client. This directory of images, I will delete this image because, actually no I won't. This directory of images is where we will store the images that the clients will upload. Coming back to here, clients are uploading to us some files. And these files are image files. In our case, we only allow image files. So do we put them in the database? We could technically put them in the database, but databases are not optimized for big binary files like images. Databases can handle them, but not particularly well. So it is usually better, if you're dealing with binary files like JPEGs and PDFs and stuff like that, it's usually better not to put them in a database, to put them in some kind of file storage. And our file system is a very sensible place to put this. So we will keep our files on our file system. And that's why we created a directory called images in client. And we put readme.md there to say these images come from the client. And we also put user SVG, which is this little grayed out unknown person avatar. So that is our files. That is our image files anyway. We will be uploading there. Next. So this was the README, and we also have the user PNG. Is it now SVG, Rich?
That question?
Why does this say SVG and this one says PNG? I haven't updated that. Interesting. So that's the unknown user. Oh, yes, of course, because I didn't have the most new version when I was updating these. All right. Then we have changes in the client. We have changes in the client because we have to support the putting of avatars in the page and the uploading of avatars. Before we look at the JavaScript changes, we will look at HTML changes on the client. We have in the header of the page, which is our uploading block, what we have there is an input of type file. That allows the user to select a file. And we are saying except image PNG, image JPEG, we are only allowing these two types of files to be selected by the user. This is not a security mechanism, this is just usability. We want the user image picker to only select images. And this also works on mobile, where you would have this kind of button, upload an image. You could click it on your phone and it would allow you to just select an image from whatever image apps you have on your phone. Then we have the two default messages that are in the page before we load messages from the server. And we have added this image class avatar, and we put the user.png, or in our newest version, user.svg in there. That's our default user image. So these are the changes in HTML. In JavaScript on the client, we have to, when we are showing a message, we have to put an img element in there so that it actually shows up. And that img element will have a class of avatar, which is then styled to be nice and small like this, and to be nice gap away from the actual message. And we put the source of the avatar of the message, we put the URL of the avatar image from the message in the source of the image element. But if the message does not have an avatar, we use this default value instead, images user PNG, in the newest version SVG. And then we put this image in the new item. So if I inspect this list item, we have this list item with this image avatar and the text. And we use prepend to put the image before the text, because we chose that the avatar images go before the text. That's good. What else do we do in the client? When we are submitting a message, we have to submit the file as well. Previously, we just took the value of the message, that text, and we put that in the body of the submission as stringified payload. So the payload had one value MSG inside it. But now we have to submit a file as well. And we don't want to submit this file as a stringified binary bit in JSON, because that would be a bad idea. It would be very, very inefficient. We would have to load the file into the page and then transform from binary to some textual that can go in JSON, and then we would have to put it in the JSON block. That would be very bad. So what we do instead, we submit the file alongside our payload as something called form data. Forms have been there for a long time in HTML pages. This is a form input element, this is a form file input element, and this is a form button. We can submit these an old way, where no JavaScript gets its hands on it and it just gets submitted. And that format for submitting it is called form data. So we can create that format in JavaScript as well. We can put our payload in there as JSON, and we can also put the file in there. If we have a file in our if we have a file selected in this select button, then we add that file to the form data. So we are submitting two things here, the MSG, which is the text, and also the avatar image, if we have one, under the name avatar. We are now no longer submitting JSON, we are now submitting a text and a binary file. And then instead of JSON stringifying the payload, we just give the payload to fetch. Fetch knows about form data and it submits it correctly. Now, the final thing here we have is a handle on the avatar selector. That is just part of how we get to these elements in the page. That was the client-side JavaScript code. In CSS, we set the avatar to be nice and small and everything. Let me close that. It's not very interesting here. And then we will deal with changes in the message board because it has to accept avatars. But we will also deal with changes in the SQL because we now have to add some kind of information about the avatar to the database. Let me go to the source code here and bring up this migration file. Actually, let me bring up both migration files. We have one initial and two file. I'll put them top to bottom like this. In the initial file, database version, we had a table of messages with ID, message, and time. Now, we need to keep track of the avatar files. These avatar files will live on our file system, so they will have a path. So we need to add a new thing to the database that keeps track of the file for the avatar. And we just do it with a column file. Alter table is an SQL command. I don't know if you've seen it already in your databases, but if you haven't, you will. So alter table is able to add a new column to an existing table. So we are adding a new column. We give it the data type just text because it will be a file path, and that's it. And if we wanted to downgrade from having avatars to not having avatars, we ignore this. We recreate the table, but yeah, we don't need to look at the down migration. The up migration is just adding a new column. So we will have a new column in the database. Very good. We will be able to deal with that in a few moments. So that would be the new migration file that adds a new column. Then we have changes in the message board. We have changes in the message board code, which have to deal with the files. But we first have to deal with the files in the server code. The server in its API has to be able to accept an incoming file. We add that to the post route where we accept a new message. We add something that we call uploader, which comes from a package called Molter, which we use here. And Molter can deal with form data, and we tell it where to upload files and what the limits are for security. And then we can upload a single file, avatar, that's the name we gave it in the client. And we upload this, Molter accepts it, and when there is a file called avatar, this post route, this post message function will now get a handle on it. And the post message function gets the file from rec.file. Request.file is where Molter, which we call uploader here, puts the uploaded file. So we have it as part of the request. And it's an object of type file. It has various interesting things. So we take that file from the request, which Molter has accepted for us. If we didn't have this uploader in here, we would not be able to accept any files in our post route. And we take the file and give it to the message board, code. And then we can have a look at the message board code, because what we are changing is most everything. Most everything now has to deal with avatars. And there's an interesting complication there. That will be the last thing that we will look at here today. When we upload files to the server, we shouldn't upload them immediately to where other clients will see these files. We have created client/images where we have these files. This is inside client, so the clients can actually load these files. This comes from the server, from the client directory. And it's this file 895A and so on. But when a user submits a file, what if that file has a virus? What if that file is not actually an image? What if that file is too big? Or so on. We don't want to accept just any file. We want to accept just only image files. So we should be able to check for that image before anybody can see it. So we don't let clients upload into client images. We let clients upload to a new directory called upload. So we had to create a new directory for this. And that is what we gave to Molter. Molter is uploading into upload, not into client images. In the database code, in the message board code, we then have to deal with that. When we add a message, we can get a file. And if we have that file, if the message came with a file, we check whether it is an image. For now, we only do it by the incoming MIME type. The browser is telling us that it's an image, but that is not secure enough. We would need to actually use some library that tells us this file is in fact an image and it's safe and doesn't have any viruses and so on. Then we create a new file name for the incoming file, which contains the PNG bit in there, or the JPEG thing in there, because then the server can serve it correctly. And only when we have accepted the file, which we would do instead of these comments, only then we move the file from upload into images, and then it becomes public. This kind of checking is left as an exercise for you. There are libraries on NPM that tell you the type of an incoming file based on its contents, and then you can go, if it's an image, then yeah, absolutely accept it. And we move the file with rename from upload into the client visible folder. And then we can serve it. So that means list images now needs to care about the files as well. The files are in client images something. But this directory could change. We might want to change what the file name is. So we have a special function here, add image path, that deals with that directory. We just store the UUID of the file. And on the client currently, it's seen inside images. If I just open this image in a new tab, this file is inside /images. So we have to add to the file path /images, and then the client will know where to look for it. There's a lot of content in here. We won't require you to know about file upload for your coursework or for anything marked in this year. And we will revisit uploading files in second year again, because it is a very important kind of functionality. But we have it as part of the staged message board because it's a natural part of the example. So we have shown you this stage 10 where we upload files as well. Look into it if you wish, or you can choose to let it just stay there in the background for year 2 and then revisit it. This concludes our morning lecture, where we looked at putting data in the database, but also dealing with files that do not belong in the database. Do we have any more questions? Cosmin Gabriel asks, make something that checks type of file and size. Yes, exactly. We could do that. There is npm file type. There must be a library. One is called just file type. And what does it do? The file type is detected by checking the magic number of the buffer. So we have a file in memory or on the disk, and we check something called a magic number. And most file types have a different magic number. That is just the first few bytes of the file. And then this simple library can tell us that. It doesn't check that the image is not malformed. You could do that with more involved code.
I'm
Any
going
other
to put
questions?
a link into something here. It's called DDFI, which is the drag and drop file inspector. It's not something we normally use for teaching. It's just something that I wrote a few years ago, but it's an example of how you can use drag and drop on a client in order to inspect information about the file and then process it in different ways. So basically, once you run it, you can drag stuff from your desktop onto it. So you're putting stuff into the browser, but then it will analyze the content. So if it's an image, it'll show you bits about the image and things like that. So there's plenty you can do.
I have just used it. I have opened the file and dragged my image in there, and the browser tells me it's image JPEG, there's modification time, there's an MD5, a lot of useful stuff, including the size, yes.
Yep. So yes, you could do all sorts. You could even look at it and maybe do some image processing with the canvas element in order to take it from being the large file that it is now to shrinking it down to a proper thumbnail size that would be good for an avatar, and then maybe let the user drag which portion they want to be their avatar. All sorts of things you could do. What we've shown is the raw ugly stuff that's necessary in order to make it work.
Indeed. And you do need something like Molter, and we recommend Molter to deal with incoming binary files.
We're out of time. Thanks, everybody. We will see you all later in the week.
Cool, brilliant. Thank you all.
Bye for now.